Hi folks, Mr. Long here. What I'm going to do now is just go through some of the algebra of ln and e, briefly explain what ln is. So if we had y equals 2 to the x, so you'll need these algebra skills to solve equations for derivatives. So if I had y equals 2 to the x, and we know that that is just an exponential growth curve like so, and we know the inverse of that is y equals the log of x to the base 2. And that looks like so, something like that, right? So, and we also know, by the way, that the x-intercept for any log is at 1, 0. And why is that? Well, because the exponent, if you take 2 and you raise it to the exponent of 0, you get 1, right? So just remember that what's important here is that in this, the y value is what's called the evaluated power. So that's the answer, like 2 to the 3 is 8. And the exponent is on the x-axis, so the logarithm is the inverse. So that means that the exponent is on the y-axis, and the evaluated power, the answer, is on the x-axis. So, so if you look at that, so that's the evaluated power, that's the exponent. So if you have an evaluated power of 1, what exponent was on the base? Well, it had to be 0. So that's why you get an x-intercept there. Just like 2 to the 0 equals 1. That's why you get a y-intercept of 1. So remember, inverse functions, y-intercept of the original function is the x-intercept of the inverse function. So how does that relate to e? Well, if we have y equals e to the x, and remember e is just an irrational number of 2.7183 ... just like pi. So if I have y equals e to the x, then there's a logarithm inverse of that, which is y equals the logarithm of x to the base e. Well, what we do though is we short form that and we write it as ln of x. So we call it the natural logarithm function. Okay, so if you see ln of x, you know the base is e. And just really quickly, I want you to imagine, so if we said, what is the cube root of x cubed? Well, that's just x, right? And why is it just x? Because it's you're composing an original function with an inverse inside of that. The inverse of cube root is x cubed. So similarly, if you have e to the ln of x, that just equals x, right? Because you're putting ln is the inverse of e, so that equals x. And then, of course, the ln of e to the x would equal x. Okay, that's important. Those are inverse properties. And you learned that anyway in the logs in advanced functions. Okay, so hopefully you've seen the video on the log rules review, which I think is pretty important to watch. And I would take notes definitely when you did that, because that's where you will have reviewed these rules here, right? Okay, so let's move this up right here and go through this. Okay, here we go. So we're going to start by solving this equation. So again, remember, that's no different than an equation where instead of e, you could have that as 2.7183 ... E is just our short form. So how do you solve an equation like this? You use all the same rules of inverse operations. So you're going to start by minusing 7 on both sides. 15 e to the 1 minus 3x equals 10 minus 7 is 3. Next, you're going to divide both sides by 15. E to the 1 minus 3x equals 3/15. That simplifies to 1/5. And now, what you want to do is take, just like you would have taken log base 10, because we know the inverse of e, right? The inverse of e is ln. So we take the ln of both sides. and then I end up with the ln of e to the 1 minus 3x equals ln of 1 minus the ln of 5, because remember that when you're taking the logarithm of a quotient, you can subtract the exponents. Okay, so ln of 1 over ln of 5 is ln 1 minus ln 5, and we know that the ln of 1, any log with an evaluated power of 1 is 0. So we end up with, and on this side, using the power rule of logs, it's going to become 1 minus 3x multiplied by the ln of e is going to equal negative ln of 5, because that is 0. Okay, so there's some big things here. The first one is the power rule of logs, so that's where you can take this 1 minus 3x and multiply it by the ln, because remember you've got e is the evaluated power in this case, and that's your exponent. So you have an exponent on an evaluated power. Well, exponent on a power is you multiply the exponents. So the ln part is an exponent, so you have an exponent on a power, so you multiply the exponents together. 1 minus 3x multiplied by the ln of e. Over here, again, we use the quotient rule of logs, which is this one here, right? So we know that ln of a over b equals ln a minus ln b. Okay, so we've done that, and we know the ln of 1 is 0. That means you're at the x-intercept. Any log of 1 will be 0. Okay, and that's for this. Whoa, sorry, folks. Any ln of 1 or log of 1 will be 0. So all we're left with is negative ln 5. So what do I have to do? Oh, then I have to recognize this. What's the ln of 1? So remember, what does that mean? And I'll write it over here. So that means the log of e to the base e. Okay, think about ln of e means the log of e to the base e. So what does that mean? What exponent do I put on e to get e? Well, e to the 1 equals e. So that's automatically worth 1. So now I just have 1 minus 3x. So now I can subtract 1 on both sides, and I'm going to have negative 3x equals minus ln 5 minus 1. Then I can divide by negative 3 on both sides. X equals negative ln of 5 minus 1 all over negative 3. Now, if I notice all of the terms in that quotient are negative, so that means that I can change that, multiply the top and the bottom by negative 1. Okay, you don't change anything if you multiply the top and the bottom by the same thing. So x then ends up equaling ln of 5 plus 1 over 3. Okay, and if you want to, you can put that in a calculator. You put that in the calculator here, and ln of 5 equals, that's approximately 0.870. Okay, so this right here is our exact value. That would be our approximate answer. Okay, so that's how you solve an equation with e. A lot of little things there. A lot of little things. So the key things are that you want to keep things in a fraction. Okay, and that's why we did that right there. Let me do this. Keep that in a fraction. What's the inverse of e? Ln. So I take the ln, you do it to both sides. Okay, so I'm taking the ln there, and I get the ln of e to the 1 minus 3x. I can use the power of a log rule. Bring that to the front. And then I can, after that, I can then expand out my log. Okay, using the quotient rule, ln of 1 minus ln of 5. When I take the ln of a quotient, the ln or log of any base with an evaluated power of 1 is 0, because what exponent do you put on any base to get a value of 1? 0. And then after that, I have to recognize that the ln of e is 1. What exponent do I put on e, a base of e, to make e? 1. Okay, and then after that, it's just inverse operations to solve. And then the last part would be this notion that if I have negatives there, and there, that I can multiply the top and bottom by -1, which doesn't change anything, and I just end up with positives. And then I have two possible answers. One possible answer is exact, one is approximate. Okay, so ln 5 plus 1 over 3, or 0.870. All right, folks, so again, I invite you to review that and look at those key things in solving these exponential equations, which you're going to need to do with derivatives. What do we get? Okay, what do we get? We get, so I'm going to go main, and I can do the fraction button, and it was the ln functions. So it was the ln of 3. Sorry, not that, ln of 5 plus 1 divided by 3. Okay, 0.869, or 0.870. 0.870. Okay, so